I want to thank everyone for coming to this talk. So it's a little more than what's new in just Entity Framework Core 3.1. We're going to probably go through most of the kind of what I find the interesting features since Entity Framework Core came out, including some features in 3.1. So I've been doing this talk every kind of version, and so we're up to 3.1. So I just kind of put 3.1 and I just kind of add stuff to the end. So we're going to go really fast, and I'm sure this 55 minutes will go by quickly. But if you have any questions, just post them, and Lee will keep track of them. If it's something that, like a big question, he can interrupt me, but we might just want to queue him up to the end. So again, my name's Chris Woodruff. I work at Quicken Loans. I am a team leader for our new developer advocate, or I'm a kind of developer advocate. We have a developer relations team at Quicken Loans that's new probably the last 6 months. So I lead that, and you can see some of my other stuff, and you can get the slide deck later. It's out on the GitHub repository, so with all the code that we're going to look at today. So the agenda is very busy, so we're going to go through a bunch of different features that I find interesting, and for most people that use Entity Framework, they may not have seen all of these features. You may have seen one or two, but you probably haven't seen all these. And really, there are so many great features that can make your data experience so much better with in ASP.NET Core and .NET Core. So we're going to take a look. So here's the agenda. So let's get right into it. So we're going to talk about restricted client evaluation. So the interesting thing with when EF Core 3.0 came out, which is now 3.1, all queries now will run and execute at the data engine, at the SQL engine that you're calling on the other side. So let's just assume that we're going to be using SQL Server throughout all this, which I do actually use, but it's no different than any other SQL backend, if it's Oracle or SQLite or MySQL or Postgres. No matter what now, all queries have to run entirely on your SQL engine. So it used to be back in the EF6 days and before EF Core 3 that sometimes a query, some of it would be run on the SQL server, and then it would return back a bunch of data where the where clause would then be applied to it. So let's take a look at this this LINQ statement. So this is getting customers, and then we're going to say where, and then it's calling two C# functions. So starts with and is special customer. So these are code on in the application that we include to kind of get some parameters that we're looking for to send over for a query. Now, this query will not execute now in EF Core 3.1 because we have those two, we have one where clause, but it is actually two things in the where clause that we're trying to do filter on. So what we have to do is call one of the C# methods. So we'll say start with, and then we'll turn that into a enumerable, which switches to link to objects, and then we'll apply the other where clause to it. So this will allow, actually it will allow multiple queries to take place. But just know that if you run into some errors, if you get runtime errors with some of your queries, it could be because EF Core cannot take that LINQ statement and send it over and run that entirely on the SQL backend. So another thing that EF Core and the team at Microsoft has done is tried to do single SQL statements per query. So if we take a look at this query, which is a blog, so it's saying go out and use the blog entity and include all the posts that for each blog that we return back, and then bring that back as a list. So in the previous iterations of EF Core, this could have caused a lot of queries to happen. So you might have gotten basically a query, you would have gotten a query to get all the blogs, and then a query for each blog to get back posts to then it would return back and bring everything together. But today, what EF Core has done, and it took a lot of work and it was kind of complex, it will take this query and create a single select statement and send that over across the wire to SQL Server to come to return back your result set. So, and if EF Core cannot translate a LINQ query into a single SQL statement, it will throw a runtime exception. So there are limits to what EF Core can do with some LINQ statements. Really depends on how complex they are. But just know that these two new features are made so that we are not kind of moving gigantic amounts of data across a wire to do things, or have multiple SQL statements that are going back and forth from the client to the database. So the next one is Cosmos DB. So I'm going to be honest with you, I'm not a huge Cosmos DB user, but it's kind of interesting. I do have the emulator. So there's an emulator that you can run locally for Cosmos DB just to test things out. And I do want to show that how we do it, and to show that EF Core can call into Cosmos DB either managed or unmanaged data well. So I'm going to jump out to my hey Lee, do you see my my IDE now? Okay.
Sorry, you got me right as I went to go get a cup of coffee.
Oh, no problem. Do you see my IDE showing?
I do see your IDE.
Okay.
Yep, you're solid.
Okay. Awesome. I just wanted to make sure. So this is a solution I have with many different kind of features, and so you can get this GitHub repository. You can download all this code. But let's go into Cosmos, and Cosmos just kind of runs one is it builds a model. This is just this code will create everything that you need in a local version of Cosmos DB, and then we will get the structured data and we'll run through that sample. So the one thing is, if I go out here to the sample, what this is really doing is showing that we can do the same type of stuff in a non SQL Server database or SQL-based database that we can, just like a SQL database. So with we can add a new context. So this is adding a new order to Cosmos DB. and then we can save those changes asynchronously, and we can go out and grab it just like we do. So we can say the DbContext uses a order entity, and then we're going to get the first order out of the data store. I'm not going to say SQL Server because it's Cosmos DB and it comes out, but it will come out very similar to the fluent LINQ statements that we write for the other like SQL databases. And so we get back this order, and we can write line everything. And we're gonna add some shipping centers. So we add those shipping centers, and I mean, we basically, there's not much difference. The difference is not in this sample code, but in the unstructured data side. So let's take a look at that, because it's kind of interesting. So we can have a DbContext, and then we have this database, and then we can call this Cosmos DB Cosmos client, because what we're doing is we have this new assembly called Microsoft.Azure.Cosmos, and it works alongside with Entity Framework Core. So what we're doing is we're setting up that database. So we're getting the database. So you have to know what database you're using in Cosmos DB, which in this case it's called Orders DB. And then Cosmos DB has this idea of a container. Now it's not as far as I know, it's not a container like Docker, but it is kind of a container of one or more unstructured kind of data repositories. And we're just calling that orders. And what we can do in here is from that container, we can come out and define a query, and we're just going to say select star from O, because remember, this is unstructured data. So we're just going to get something out of the data store, and that's going to come back as a JSON object. So, and then we'll show that what we see in the coming back as JSON from that unstructured data repository. So let's run this and see what we get. So we're just starting up Cosmos. We're getting connected to it. Takes a second. And so the first order, let's go back up to the beginning. So it exited. So we can see that our first order will ship to someplace in London. The last order will ship someplace to New York. Those came out from the, I'll say the SQL-like facet of Cosmos DB. And so we have two shipping centers. But the interesting thing is we now jump down to the unstructured data sample, and the first order will be billed to clearance house, but this is the JSON that we get back. So that really, Cosmos DB is really just a place where we can put objects into it. It's kind of like an object database or a document database. And that is the JSON that we kind of get out of it. Now everything around kind of the entity side is in this first part, and then we get some e tags and some other things, and then we get a billing address with the clearance house. But just wanted to show that you can work with Cosmos DB. It's kind of interesting. I'm going to be digging into it myself in the future, but wanted to show that off. So we will continue on. So explicitly compiled queries, these are kind of interesting. So if you had a query that was being run, say it's in an API that gets run millions of times an hour, or you're just processing stuff in an application. Maybe it's some kind of real-time application that you're having to get tons of data back all the time because data is changing rapidly. Well, there's a new feature, and this came in Entity Framework Core 2.1, I think. But we can compile, and we can compile a LINQ statement ahead of time. So we don't have to compile it each time we run it. It's kind of like, imagine we are JITting it once, storing it in a function pointer, and then being able to run it over and over again. So the top code is the declaration for my compiled query. So this compiled query takes in a LINQ statement, so we can see that it has this ef.compile query, and we're giving it the DbContext, and then but the big thing is that we're saying off of the DbContext, we're using my entities, and then we're doing a where clause, and that uses an ID. Well, that ID comes in through the compiled query. So if we want to call this, we can come down and we can just say compiled query, because that's the name of our function pointer. That's the name. See, we have, oh, sorry about that. We have this func. So we can just say compiled query, and we can give it 100, and that will run this LINQ statement that's been compiled. It's been JITted ahead of time, and we can run this over and over again without the overhead of compiling that LINQ statement over and over again. So it saves on some overhead, and I'm going to show you the benefits of it. So I'm going to come back here, and I'm going to close all of these. I'm going to come back to compiled queries, and in here, what I'm doing is I'm going to run 3 tests. I'm going to run off of this AdventureWorks DbContext. So we're running against the AdventureWorks database. So in the first test, I'm just going to do take all my account numbers that are in this database, and I'm going to grab each customer based on the account number. So this first one is using just a method like we usually see, and each time this for each runs, it has to compile this LINQ statement down. And so it has the overhead of over and over again JITting that LINQ statement, and then running it, and then getting back the customer needed. Now, in the second test, you can see that I'm compiling that same LINQ statement. I'm compiling it into a function, into a kind of a function pointer that will contain that compiled query. And then I'm going to run through all of the account numbers, but I'm going to call that compiled query to get back each customer. Now we can take it one step further, and we can do an async compiled query, which kind of takes it to the next step of efficient programming. So in here, we're going to use it and do it asynchronously. So we're going to have an asynchronous compiled query, and we're going to do the same thing. We're going to run this. So at the end of this, we're going to see how long it took each one of these tests to run. So I'm going to run this. And you can see that a regular, hopefully you can see this down here. I'll increase the font size. So the first test that we ran, which was just using regular links over and over again, that took 372 milliseconds to run through the for each loop. Using the compiled query, we knocked it down to 162 milliseconds. And then using the async compiled method, we knocked down that processing down to 69 milliseconds. So we went from 372 to 69. I don't know what percentage that is, but it is a dramatic difference between running a LINQ statement and in a normal fashion compared to an async compiled query. So if you have places in your code that you're running LINQ statements over and over again, it might be smart to look at these compiled queries. So let's move on. So reverse engineering of database views. So if anyone remembers the old days of Entity Framework and the old days of maybe the first couple versions of Entity Framework Core, you'll know that we couldn't reverse engineer and we couldn't use views through a DbContext, through Entity Framework Core, and especially with like EF6. But now we can. So this is just a .NET call to do basically for scaffolding and reverse engineering a database. So if you've never seen this, it basically is a call that you can do. It points to a connection string. It says what type of flavor of database we're using. In this case, it's a SQL Server DbContext driver. And then we're going to say include all the data annotations. So if you have columns that are nvarchar of a certain length, what EF Core will do is take those string lengths and other constraints in your data model, in your data schema for your database, and create those data annotations for you at the entity level. So for your POCOs, it will add those data annotations on. And the last thing is just saying, where do you want all the output to be put? And I just said in a folder called models. So you can reverse that, but what is really happening is we're using a new feature that came in EF Core 2.0, which was keyless entity types. And what keyless entity types is used for, it's used for mapping the views that naturally don't have primary keys, because views in general don't have primary keys. They're just a view that's created on the database on the SQL Server side. But also we can now map to tables that don't have primary keys. We can map to queries defined in the model. So if we have a custom query that we want to use, but there's nothing on the database side that we can pull in to model that, we can create those queries, and keyless entity types can be used to pull those in and use that type of data collection. And then it's also a way of returning types from like custom MySQL queries. So if you have a and we'll look at what from SQL is in a little while. It's an interpolation string for queries, but we can do very custom queries and return back result sets that don't match up with any of our entity models that we can still use using the keyless entity types. So how we use those is, we'll take a look at the code, but in the first line, the public DB query, that would be what you would add if you were adding some views into an existing DB context. You could add this DB query of blog post count, which is a entity. It's just a class that we define, and then we would give it the name of whatever we wanted for that DB query. And then down in the model builder, we would say .query of type blog post count, and then we would say that this query maps to the view name in the database. So in this case, it's view underscore blog post counts. And then we have a property, we're saying that there's a property on this view called blog name, and it has a column name of name. So that's what it would come back as. But and then we would have, like I said before, we would have this new class that would represent this entity type that would be based on that view. So what would come back is a public string and an int for each. Basically, this view for each blog, it returns back a calculated post count in the view. So that's what we get back, and we can use views that way. So let's take a look at that demo. I really like this new feature. It's actually really interesting. So let's go and find that. That is entity, and I have so many things in here. Sometimes I get lost. Okay, keyless entity types. So in here, I actually I set up a database. So this just creates a local database through Entity Framework. And I create a blog and I put some posts on it. And then I have a view right here. So in here, I execute a SQL raw statement to create the view that I need out in the database. So you can do execute a SQL raw through your DbContext. So that's another interesting thing that we can do now. But down here, when I am working with my working in my configuration, on my model creation, I'm going to add this basically this entity, and then I'm going to say it has no key. It maps to a view, so that's the view, and it has a property of name. So what this means is I can do filters. I can do where clauses on the name. So if I used this blog post count in a LINQ statement, I could basically put a where clause on that to say, hey, instead of I don't want to know all the blogs and all the number of posts per blog. I just want one. I want one name. So I'm going to give it a name, and you're going to return back a filtered result set based on that view. And then down here, we just have our POCO objects. So this is for blog, this is the blog entity, the post entity, and then we have that blog post count entity that holds the data from the view. So let us run this, and I just build it. So gotta wait a second till it builds. Now I'm gonna run. So you can see I have in here, I have a lot of logging stuff turned on, but in the end, you see that Catfish blog has 2 posts, Cat blog has 3 posts, and Fish blog has 3 posts. And whereas that is coming from is up here. Basically, I'm setting up my database, and I'm just saying in my blog context, I am going to have this query. And all I'm saying is go out to blog post count, give me back everything back from that view, and then I'm going to go through each one and write out something to the console. So in this case, I wrote out the blog name and the post count, which shows up down here in this nice descriptive sentences saying the blog and how many posts it has. So just know that you can use this keyless entity types. You can also use it with stored procedures. So I've used it with stored procedures before, but I don't have an example here. Okay, so string interpolation in raw SQL methods. So basically this is just saying that if I don't want to write a LINQ statement, I can now write actual select statements or any CRUD SQL calls. So in this case, I am creating a string variable which contains the string Redmond, which represents a city, and I'm going to do this from SQL method in EF Core. It's based off of a entity type. So in here, I'm just going to say select star from customer where city equals, and then it's using the variable city to bring in Redmond, but it doesn't actually build a one string that contains or puts Redmond into that actual string that gets sent across a wire. What happens is it builds the select statement that will be sent across a wire, and it uses a SQL variable, in this case at P0, and that P0 variable contains Redmond. So when it goes over to SQL Server will take that and put Redmond into it. Now you're probably thinking, well, that looks like SQL injection. Yes and no. I mean, I do say you have to be careful when you use string interpolation in raw SQL methods, but it does, an entity framework will take care of some of the past issues with SQL injection. So it's much safer. I won't say it's 100% safe, but it is much safer than what we used to do when we were doing just building strings and sending them across a wire. So just know you can do this. I use this when maybe I get a select statement from one of my DBAs, and it is very complex, and I cannot get it into a LINQ statement, or I don't have time to develop a LINQ statement for the SQL that this DBA gave me. So in this case, I could use from SQL and use it that way, and not have to spend that time trying to figure out a LINQ statement based on some very complex query that I get. So again, we do have examples of this. So that would be from SQL. So in here, I do have the ability. So I'm going against AdventureWorks again. When I work with this, when I send in this parameter, it's actually not sending it in as a string per se. I'm actually going to build a SQL parameter, and this is how I recommend people to use this. So I'm actually going to use from SQL interpreted, and I'm going to create this parameter it's a last name is the parameter name, and then I'm going to call it direction is input and output. I'm going to give it a size. So in this case, it takes the length of the string for the description, which is 5, because if I don't give a length, it will use nvarchar 4000. So it will create a variable, a SQL variable, nvarchar 4000, which is much bigger than I need. So I really just need that, what goes across that parameter going across, to only have the length of the string that I'm going to be sending into it. And then the value is this description. So it contains Smith. And then I send it over, and I'm going to get back all the people with last name of Smith. And if I run this, again, all I'm going to really do is send this over, but I will show you the log so you can see all the people that were found with last name of Smith. But in the log, it does show you what gets sent across the wires. So you can see it does this execute DB command, and it has a parameter that gets sent across with it, and which is named at last name. And then you can see that there is a select statement that gets sent across, which uses that parameter. So this is a great way to do to send across queries that you don't have to put in LINQ, and you can have some assurance, I won't say 100% assurance, but a good assurance that you're not going to fall into the SQL injection kind of trap. So just know that you can do this. So I'm going to go back to slide deck. And we're going to move on. So DbContext Pooling. Okay. So this is really interesting. When I discovered this, this made me very happy, because I develop a lot of APIs. And what happens, people have to realize what happens when you are working with a DB context over and over again in your application. Doesn't matter if it's a web API project or an MVC project or anything. Anytime you create or need a DB context and you're getting it out of the dependency injection container, like the code that we're showing here for this controller. So this controller, the constructor will get a DB context from the DI container, and each time it needs a DB context, it has to spin up. It gets a new one, so it has to hydrate that object. It has to set that object up, and it will use it, and then it disposes of it. It kind of puts it back and lets the garbage collector take care of it. But every single time, it needs to create a new DB context. So what that means is, if you have an API that gets created 1 million times an hour, you will get 1 million DB contexts created in that hour. And there's a lot of overhead that comes along with that. So instead, if you use DbContext Pooling, what happens is, at the creation of the application, it will create a pool of DB contexts. Initially, it creates, most time it creates 32 of them. I'm just showing 5 here as an example. And what will happen is, when this controller now gets and needs a DB context, it will get one out of the DB context pool and be given one of those, which are already created. They've already been, they're already around, so they exist. And every time it needs it, it will get one out of the pool. But what happens is at the end, when this controller goes out of scope, when it doesn't need that DbContext anymore, what happens is that DbContext will go back into the context pool. It will be all state on the DbContext will be removed, and it will be put back into a fresh, I'll say a beginning state, just like if it was created. And so I'm going to show, so most of the time when we add a DbContext to our dependency injection container, we use add DbContext. And you've probably seen this many times. If we want to use DbContext pooling, all we have to do is substitute add DbContext pool instead of add DbContext. It's that simple. So let's take a look at a demo because I want to show you how the efficiency that we get from running this. So I'm going to shut down here. I'm going to go out to context pooling. In here, I've got an application. It's going to run through a little task, and it's going to count the number of times that we're executing. So this just basically goes out and just does some LINQ statements. And each time it needs a new DbContext. So down here is where I kind of set my database up. But we're going to do the simulate request async. So this is the call that we're basically calling over and over again for this test. And we're going to run it first. As you can see here, let me go and find the DbContext. So I'm going to go add DB. Okay, so down here in configure services, initially I'm going to say add DbContext. And then later I'm going to run it again showing the pooling. So let's show what this does. Well, and I hit the wrong one. So let's run DbContext or run context pooling. And you can see that we are kind of creating a bunch of contexts and we're showing everything. So we created, in this little test, we created a little over 48,000 DbContexts in this test, and we got requests per second. This got could perform and did perform 4,743 requests per second. Now, if I uncomment this line and then comment this line out, and I run it again, we will see how many DbContexts we created and our throughput, how many requests we got per second. So you can see that we only created 32 right away, and we're not creating any more. So again, we had 32 DbContexts that were created for this application. So right away, the overhead on the memory was lower because we didn't have all these DbContexts created over and over again. And we got almost double the number of requests per second. So imagine you are building an API using ASP.NET Core Web API, or soon ASP.NET 5 Web API. you could use DbContext to gain a huge performance boost for those APIs because of not having to create the DbContext each time it's being called out of the dependency injection container. So let's go back to our slides and see what's next on our list of goodies. Database scalar function mapping. So I'm not going to show any code on this, but I'm going to show an example. So in your DbContext, you can create these DB functions. They have to be a return type of a scalar type. So in this example, I am returning, I'm going to return back, and it's just throwing example because there's no, I didn't want to put all the code into this method, but basically what it does is for each post, we're going to calculate the number of times that post has been read. So we can create a LINQ statement in here, which will go out, query the database and say, hey, for this, well, this says blog ID, but for this ID, give me the number of times this post was read. And we can even use it in other LINQ statements. So down here, I can do a show me the posts that have been read more than 5 times. So we can actually use these database scalar functions that are created at the DbContext level inside other LINQ statements. So it gives us even more and different ways to write and query and write even more exciting queries and LINQ statements against our database. So query tags. If you're a DBA, or if you know a DBA that finds that gets frustrated with you because they're always finding queries that are not optimized. So I know I have worked with DBAs that find queries that because that's their job, they find these queries that are not optimized, and they come back to you and they go, here's a query, it's not optimized, but I think I can fix it. Maybe we need to put another where clause or change it slightly. Where is it in the application? And you go, I don't know, I have to look. Because you're thinking in LINQ, they're thinking in select statements, and sometimes it's hard to know what that select statement looks like from a LINQ. Maybe you have a lot of LINQ statements that sort of look a lot alike, and you just don't know which one it is. Now you can, and now you can send over comments, these query tags, across the wire with your select statements. So in this case, I have a spatial LINQ statement that goes out and finds my friends that are closest to me based on my location. But you can see this tag with method that sends over this string. It says this is a spatial query, and what gets sent across the wire to SQL Server is this. Actually, it gets sent over a comment. When that gets sent over, that actually gets stored in the log over in SQL Server. So that will show up, that comment will show up in the raw, some of the raw values when you're looking at a query plan. If you're looking at the query store, which is a really cool feature of SQL Server since 2016. So query store can show you lots of queries, but it can identify those queries that are not running well. And these comments, these query tags will show up with the raw, some of the raw values that that can be shown in query plans in the query store. So now your and I will show I'm not going to run any code, but I will show you how I use it. So query tags, I try to write something like this. So here's a LINQ statement, and I have three tag with methods on this. One tells the description of the of this LINQ statement. Two, it shows the location, so it's in query tag dot program dot main method. So I put in the namespace, and then I also say what parameters are being sent across the wire with this LINQ statement. And these tags come across. So now if a DBA finds a query from me that they want to change and help me optimize it and go from 10-second runtime to 500 milliseconds, they know basically where it's at because I give a description, but the important one is I'm giving the location in one of these query tags. So look into query tags, talk to your DBAs about it because it really helps with knowing and communicating back and forth. Lee, how much time do I have left?
You could run up till 8 minutes if you don't want to take questions, but
Okay.
we do need to switch over at 3.
Yeah. Okay. So I'll quickly go through this. So in asynchronous streams. So we have the ability now to have run or build a LINQ statement and do a wait for each, and that will basically allow you to walk through the result set from the database. So just know that we do have these streams that actually they go along with the C#8 anonymous or asynchronous streams. So they're very similar to that. But we do get that ability in Entity Framework Core. So global query filters. I have code examples for this, but I'll quickly go through this. When you're building your DbContext, you can actually put filters that will override and be included in all SQL statements or all SQL that goes across the wire. So in this case, I have a query filter, and I'm going to say that for all posts that are deleted, do not allow any of those deleted posts to be brought back through any queries. So if I ran this LINQ statement that said DbContext blog include posts, so this returns back each blog and also a subquery for all the posts that, or the first one based on an ID. But if this blog had deleted posts, it would not have any of those posts returned. So think of this as an easy way for you as a software architect to put some constraints into your DbContext. So people don't have to remember to not include deleted posts, in this case, coming back from your database. Also, we can do spatial. So in this case, we're using a namespace called Microsoft.NetFrameworkCore.SQLServer.net topology suite. And what this can do is allow you to use some of the spatial features of SQL Server. And this is just a way to add that at the time when you're building your DbContext or configuring your DbContext. You just do the use net topology suites. And we have this friend entity, and this friend entity has a property in here called point, and that's going to be the location. So it's the location of where that friend exists. And I can add that through DbContext. I can add a point based on geometry into that location. And then I can do a query. I can build a LINQ statement to say, show me the 5 nearest friends from my location. So I'm going to send in my location. It's going to return back from the database the closest friends around me. So just know that Entity Framework also, or Entity Framework Core, will also allow you to use spatial types that SQL Server has. So here's some information, just like where you can get the docs for EF Core, where EF Core lives out on GitHub. They do have a blog. Most of their blog content does fall under the .NET blog. And then also all the demos and the slide decks that you saw today are out on one of my GitHub repositories under EF Core 3 demos. And so again, my name's Chris Woodruff. Here's a little information about me if you want to get a hold of me or follow me on Twitter or connect with me on LinkedIn. Usually you can find me in lots of different places. So Lee, with remaining time that we have, we can go through questions.
Yeah, actually, first of all, that was a fantastic presentation. I learned a ton, so thank you very much, Woody. Nobody actually asked any questions other than me, so so far that I see. Okay. So I'll just go through. I'll go through a couple of questions that I had in the last 3 minutes. Here's one. I was curious. Okay, the database context pooling looks amazing, and so it seems like because you can because it resets the state, there shouldn't be any like caching or security leakage, right? So why would you not use it? Are there any downsides?
So one thing that maybe you don't want to use it is when you do want to save the state. So say you have say you do want to have a DB context and save that state over a long period of time, that I wouldn't do it that way. So or if you create a DB context, I've seen people that create DB contexts as singletons, and they keep that DB context around for a long time for whatever purpose. But for I'll say 90% of the time, there is no reason why not to use DbContext Pooling.
Awesome. Stan asks, is there any reason or condition not to use add DbContext Pool instead of add DbContext if the add DbContext Pool's performance is better? It's basically the same question I just asked, isn't it?
Okay. Yeah. I mean, it will give you a performance boost. It's just if you're okay with those DB contexts getting their state being stripped off when they go back into the dependency injection container.
Can you answer this in, it's a how question, you probably can't. Can you answer this in 1 minute? How does the perf of explicitly compiled queries compare to stored procedures?
Ooh, good question. You know what? I have not tested that. Tell that person, whoever it is, that is that is a great idea. And I will look into that. For me, it's just a way to take those LINQ statements that are being run over and over again, especially in like APIs, and compiling them and using them. But here's a thing you have to remember. Sometimes there is some things that are broken in Entity Framework Core 3.1. So some cases where you're trying to use compiled queries will not work. So some of the stuff got broken when they migrated and they came up to EF Core 3. So
awesome.
That's it.
Well, yay! Thank you. That was wonderful. That was a really insightful presentation.